Hi everyone, we're going to find the intervals of increase or decrease, find the local maximum and minimum values, find the intervals of concavity and inflection points, and use our information to just sketch. This is really a rough sketch of the graph. Okay, and this is our function, h of x. So we first want to say, take the first derivative to test for increasing and decreasing. So when you do that, you're going to do h prime of x. I'm looking at this, and that gives you 15x squared minus 15x to the fourth. Now before we set this to 0, we want to factor out the 15x squared, and that gives us 1 minus x squared. And simplifying this further, we get 15x squared. Let's expand this 1 minus x and 1 plus x. So your critical numbers are x equals 0 for this piece, x equals 1, and x equals negative 1. All right, so now let's do a sign graph, sign diagram, and plot these. So I'm going to put my smallest number here, and this is where we're going to find our intervals, increasing or decreasing. All right, so we want to know our first interval is going to be x is less than negative 1. Then we have x is in between negative 1 and 0. X is in between 0 and 1. And x is greater than 1. And then we test values like that. So basically, if I plug in negative 2 into this piece, it's going to be positive. In fact, whatever I plug in here, it's going to be positive because you square it out. If I plug negative or positive. If I plug in negative 2 in here, it's going to be positive. Negative 2 in here, it's going to be negative. So that's going to be 2 positives make a positive. Multiply that by negative, you get negative. So this is a negative. Now let's plug in negative 1/2. If I plug in negative 1/2, I still get positive for the first one. Negative 1/2 gives me positive here. And negative 1/2 here gives me a positive. So 3 positives give me a positive. Now if I plug in 1/2, I get positive, positive. Let's see, what did I get for this one? Positive again. So this is positive. And if I plug in 2, I'm going to get positive. This one's going to be negative. So 2 positives times a negative is going to be a negative. So all this tells you is this is decreasing, increasing, decreasing, increasing. And if you want, you can write your intervals as negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity. And basically, the graph's going to be like this. The interval's decreasing. Let me move it over a little bit. Decreasing to negative 1. Then it's increasing. Basically, we can say it's increasing. Let's rewrite this. Increasing from negative 1 to 1. So it's increasing all the way up to here to 1. And then it's decreasing. All right. So increasing, decreasing, decreasing. All right. Now, so therefore you can actually see this is a minimum value and this is a maximum value. So what you're going to do is plug in h of negative 1 and h of 1 into this equation here. And you're going to get negative 2, which is your local minimum. And when you plug in 1, you get 2 is your max. So we're going to be plotting these points or sketching it to help us graph. So these are your local min and max. All right. Now we're going to take the second derivative to do concavity. And I'm going to go ahead and do it on this slide so I can see what I have here. So the second derivative, or h double prime of x, is 30x minus 60x cubed. And that's what we're going to write on the next slide. So we have h double prime of x equals 30x minus 60x cubed. So let's factor that. And we're going to get 30x times 1 minus 2x squared, which equals 0. Okay, so we have x equals 0. And then let's solve for this one. So 1 equals 2x squared. 1/2 equals x squared. Square root both sides. And don't forget to put the plus and minus. So basically a plus and minus 1 divided by square root of 2. So we have x equals 1 divided by square root of 2. And x equals negative 1 divided by square root of 2. So that's what we're going to do, check for our concavity test. All right, I'm going to kind of erase some of this. Now, another thing, it's always good to know your square root. Square root of 2 is about 1.41. So what we really have is 1 divided by 1.41. All right, which is smaller than 1. So let's do a little sign diagram. So I'm going to put negative 1 divided by square root of 2, 0, and 1 divided by square root of 2. And check for concavity. So we want x is less than negative 1 divided by square root of 2. And let's see, x is in between negative 1 divided by square root of 2 and 0. X is in between 0 and 1 divided by square root of 2. And x is greater than 1 divided by square root of 2. Very tight there. Now, all we do is go back to this equation and plug in some values. So for the first one, x is less than negative 1. So let's just plug in negative 1. If I plug in negative 1 here, I get negative. Negative 1 here is negative. So that's going to be positive. That means concave up. Now, with our 1 divided by square root of 2, we need to know what's in between that. So we know this is 1 divided by 1.41. So I'm just going to try 1/3 because 1/3 is in between there, negative 1/3 in our case for this one. So if I put in negative 1/3, I get negative here, and I'm going to get, let's see, this is going to be positive. So a negative times a positive is going to be a negative. So this is concave down. Now I'm going to plug in 1/3, and I'm going to get a positive, because this is going to be positive times a positive. So that gives you positive. And now we're going to plug in a big number. Let's just plug in 1. You get positive, and then you're going to get a negative. So positive times a negative is negative. So concave up, concave down. Now, once we have that, we're going to figure out the points for that. So we're starting at concave up, and our points are here. And we can graph this. So let's look at f, or h of 0 equals 0. And h of 1 divided by square root of 2. And I already did this. So this is going to be 1. This is going to be 7 divided by 4 square root of 2. and h of, let's see, h of negative 1 divided by square root of 2, that's going to equal negative 7 divided by 4 square root of 2. So basically, it's concave, and then what you want to do is write your intervals. It's concave up on negative infinity to negative 1 divided by square root of 2. It is concave down on negative 1 divided by square root of 2, comma 0. Concave up 0 to 1 divided by square root of 2. And concave down at 1/2, 1 divided by square root of 2 to infinity. So that's what we're going to be looking at. And then we do the graph. I already started the graph. It's kind of a makeshift graph. So basically, I plotted my minimum value and my maximum value. We had 3 inflection points, and they are here, 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 and here. So let me try to go through this graph with you. So we know from negative infinity to negative 1, it's decreasing. We know from negative 1 to 1, it was increasing. So this whole graph is increasing. All right. And then from 2 to infinity, we are decreasing. And again, we're just sketching the graph. The only reason I have a grid here is because I'm working on the iPad so you can see it better. And as far as the inflection points, we have one here. So that means from negative 1 to negative 1 divided by square root of 2, that was concave up. You see it's concaving up. From negative 1 square root of 2 to 0, that's concave down. So it's kind of going like that. And then it's concave up from 0 to 1 divided by square root of 2. So it's kind of going upish. Then it's curving back down. Sometimes it's hard to see it. So I'm kind of exaggerating it here. And then those are your inflection points right here. So I'm going to draw the arrow here. These are your three inflection points. And then you can always check with your graphing calculator. And that's it. Thank you. Have a nice day. Bye-bye.